Imagine you've built the fastest, most powerful car in the world. It's incredible. But as it gets faster and faster, you suddenly realize you forgot to install brakes or a steering wheel. That's a little bit like the situation we could find ourselves in with artificial intelligence.
And it's that exact problem, how to build the brakes for AI, that is at the heart of a fascinating paper we're looking at today. It's titled Technical Requirements for Halting Dangerous AI Activities by a group of researchers from the Machine Intelligence Research Institute.
Welcome to Daily Papers, the podcast where we break down cutting-edge research into everyday conversation. And this paper is a big one. It's not about whether AI is good or bad, but about being prepared. It asks, if things started to go wrong, could we actually stop them?
Exactly. The authors start by laying out four major risks that super powerful AI could pose. First, there's loss of control. This is the classic sci-fi scenario where an AI starts pursuing its goal in ways we didn't intend and can't stop, potentially with catastrophic consequences.
The second is misuse. This one's easier to imagine. A malicious group or individual uses powerful AI to design new bioweapons or to launch devastating cyber attacks that could shut down a country's power grid.
Then there's geopolitical instability. Think of the Cold War and a nuclear arms race. An AI arms race, where countries are rushing to build the most powerful AI to get a strategic advantage, could be incredibly dangerous and trigger conflicts.
And finally, there's concentration of power. If one company or one authoritarian government develops a dominant AI, it could lead to unprecedented levels of surveillance and control, basically locking in their power forever. So with these cheerful scenarios in mind, what's the solution?
Well, the paper proposes we need the ability to enact a coordinated halt. That's the key phrase. It means having the technical tools ready to pause or restrict the development of dangerous AI across the globe, if we all agree it's necessary. The big question is, how?
And the answer, according to this paper, comes down to one main thing: compute.
Right. Compute is just the technical term for the processing power needed to run these massive AI models. You can think of it like fuel for a car. Advanced AIs are incredibly thirsty for this fuel, which comes in the form of highly specialized computer chips, or GPUs. If you can control the fuel, you can control the car.
So the first step is knowing where all the fuel is. The paper suggests we need to get serious about chip location tracking. This could mean tracking shipments of these advanced chips from the manufacturer, just like a package.
But it gets more high-tech. They propose things like hardware-enabled location tracking. This is like putting a tiny, secure GPS inside every advanced AI chip, so authorities could remotely verify where it is and that it hasn't been moved to a secret, unauthorized facility.
And to make tracking easier, they suggest centralizing compute. Instead of these chips being scattered all over the world, you'd have them in a small number of secured, registered data centers that can be easily monitored and inspected.
Then you can go a step further up the supply chain. Instead of just tracking the chips, you can control the factories that make them. These fabs, or factories, are some of the most complex and expensive facilities on Earth. There are only a handful of them capable of making the most advanced AI chips.
So if you can monitor these fabs, you can control the global supply of cutting-edge AI chips. You could put limits on how many they produce, or even verify that the new chips they make have those governance mechanisms, like the kill switches we mentioned, built right in.
Which brings us to the next layer: monitoring what the chips are actually being used for. It's not enough to know where a chip is. You need to know if it's being used to, say, cure cancer or to design a rogue AI.
This is where things like compute thresholds come in. You define a limit, a certain amount of processing power that is considered too much for any single AI training run. Going over that limit would trigger an alert or even an automatic shutdown. It's like a circuit breaker for AI development.
But what if someone gets a hold of the AI's source code? The paper calls this proliferation, which is a fancy word for the secret sauce getting out. Even if you don't have a giant data center, if you have the blueprint for a dangerous AI, you might still be able to cause harm.
The blueprint for an AI is essentially its model weights. You can think of the model weights as the learned connections in the AI's brain. The paper says we need to treat these with extreme security, like nuclear codes, to prevent them from being stolen or leaked. It also suggests we should be very careful about making the most powerful models open source, where anyone can download and use them.
So you have all of these technical tools, tracking chips, monitoring factories, setting compute limits, and securing the AI models themselves. The paper then outlines a few different plans for how you might use them.
One of them is called the Chip Production Moratorium. It's pretty much what it sounds like. It's a global agreement to just pause the production of the most advanced AI chips, hit the brakes on making anything more powerful for a while, giving everyone time to catch up on safety research and governance.
And then there's a more reactive plan that they call the last-minute wake-up. This is the emergency scenario. It assumes we don't act until something really bad happens, a rogue AI incident or a major misuse. At that point, world leaders would have to scramble to implement all of these measures at once, tracking down all the chips, shutting down data centers, and trying to contain the problem. It would be much, much harder.
Which is really the paper's core message. The time to build the fire station is before the city is on fire. All of these technical interventions, from tracking chips to designing kill switches, take time to develop and implement.
Exactly. The authors are making an urgent plea. They're saying that if we want to have any hope of steering AI development in a safe direction, we need to start building these governance tools right now. Without a steering wheel and a brake pedal, we're just passengers in a car that's getting faster every second, and we have no idea where it's heading.